Welcome to our YouTube channel, Maths Point. In our last tutorial, we talked about angles and the different types of angles based on their measures. Now, in our today's video tutorial, we'll be talking about the pairs of angles. So, we'll be starting our today's tutorial with the first pair of angles as adjacent angles. As the topic is saying, pairs of angles, so it simply means two angles. So here we are talking about adjacent angles. So we'll be taking two angles and we can say two angles are said to be adjacent if the first point is they have a common vertex. That means both the angles should be having a common vertex. Then the second point is they should be having a common arm. If we will draw a figure like this, so it's one of the angles that we are taking here, and we will draw one more arm so that we'll get two angles with same vertex. So here we are having these two angles. Let's name the different arms of the angles A, B, here AC, and then A and D. So we are having three angles here, and the angles are angle BAC, then second one angle CAD, and the third one as angle BAD. So the different pairs that we'll be taking here are angle BAC and angle CAD. This is one of the pairs of angles. Then second is angle BAC, angle BAD. Then the third pair is angle CAD and angle BAD. So these will be the different pairs of the angles in this figure. Now we will see which pair will be called as adjacent angle. As we can see in the first pair, angle BAC and CAD, we are having same vertex, which is vertex A. Then we are having a common arm, that is AC, in both these angles. So both the angles are having common vertex and a common arm. Similarly, in the second pair, angle BAC and BAD, again we are having a common vertex, that is vertex A. Then we are having a common arm BA in both these angles. And in the third pair, we are again having a same vertex, that is A, and a common arm AD. Now, which pair will be called as the adjacent angle pair? For that, we are having third condition, which says the non-common arms lie on the either sides of the common arm. That means the non-common arms should lie on the different sides of this common arm. If we'll take the first pair, the common arm is AC and the non-common arms are lying on the different sides. Here, AB is lying on one side and the other non-common arm AD is lying on the other side of this common arm. If we'll take the second pair, so this pair angle BAC and CAD, we can call this as adjacent pair of angles. Now if we'll take the second pair in which common arm is BA, but both the non-common arms are lying only on one side of this common arm. So we can't classify this pair as adjacent angles. Similarly, in the third pair, angle CAD and angle BAD, the common arm is AD and the non-common arms are lying only on one side of this common arm. So we can say that this pair is not also adjacent angle pair. So only pair of adjacent angle in this figure is angle BAC and angle CAD, as it is having common vertex and common arm. Also, the non-common arms are lying on different sides of this common arm. So we got the pair of adjacent angles here. So again in this figure, we are having angle BAC and angle CAD as the adjacent angles as they have common vertex, common arm, and the non-common arms are lying on the opposite sides of the common arm. Now, the another pair of angles that we'll be talking about is complementary angles. We know that a pair of angles is said to be complementary if their sum is 90 degrees. For example, we are having a figure here. If we will consider this angle 1 and angle 2, we can see that the non-common arms of these two angles, angle 1 and angle 2, they are making a right angle, and we know that the measure of right angle is equal to 90 degrees. So we can say angle 1 plus angle 2 is equal to 90 degrees. So angle 1 and angle 2 are complementary pair of angles. Similarly, if we will take non-adjacent pair of angles, just like here, angle 1 and angle 2, the sum of these two angles, angle 1 plus angle 2, is 60 degree plus 30 degrees, and together their sum is equal to 90 degrees. So we can say that these two angles, angle 1 and angle 2, are complementary angles. Thus, in both the figures, figure 1 and figure 2, the sum of the angles is equal to 90 degrees. So angle 1 and angle 2 are complementary angles. Now, the another pair of angle that we'll be talking about is supplementary angles. And again, we know that two angles are said to be supplementary angles if their sum is 180 degrees. They can be adjacent, they can be non-adjacent. As we can see in this figure 1, the angles are adjacent, angle 1 and angle 2, and their non-common arms are forming a straight line, and the measure of straight line is 180 degree. So we can say angle 1 plus angle 2 is equal to 180 degrees. Thus, we can say angle 1 and angle 2 are supplementary. Similarly, if we will take the two angles in the figure 2, in which angle 1 measures 120 and angle 2 measures 60 degrees. So if we will add these two, so it will become 120 plus 60 degrees, and together their sum will be 180 degrees. This we can say in both the figures, angle 1 and angle 2 are supplementary as their sum is 180 degrees. Now, the another pair of angles that we'll be talking about is a linear pair of angles, and two angles are said to form a linear pair of angle if they are adjacent angles. That means they have a common vertex, common arm, and non-common arms are lying on opposite sides of the common arm. And second is they are supplementary. That means their sum is 180 degrees, or we can say their non-common arms form a straight line. So we are having this angle 1 and angle 2 as adjacent pair of angles, as and their non-common arms are forming a straight line, so it means their sum is 180. It means they are supplementary pair of angles. Thus, two angles are said to form a linear pair of angles if they are adjacent as well as supplementary. And related to linear pair of angles, we are having linear pair axiom, which says if a ray stands on a line, then the sum of two adjacent angles so formed is 180 degrees. If we are having a line and then if a ray stands on this line like this, so we are having here two angles which are adjacent, angle BAC and angle DAC. So the two adjacent angles formed here will be having a sum of 180 degrees, that is angle BAC plus angle DAC is equal to 180 degrees, and this statement is in the form of an axiom here, so we need not to prove it. Then we have another statement which says if we are having two adjacent angles and if their sum is 180, then their non-common arms will form a line. So these are the two statements from linear P and axiom. The first one says if a ray stands on a line, then the sum of two adjacent angles formed is 180 degree, and if the sum of two adjacent angles is 180, then their non-common arms will form a straight line. So these are the two statements in the form of axioms related to linear pair of angles. Now we are having one more pair of angle, and that is vertically opposite angles. We know that when two lines intersect with each other, four angles are formed, just like here. We are having two lines, line L and line M. These two lines intersected with each other at a point, for example P. Then four angles are formed, angle 1, angle 2, angle 3, angle 4. As per the definition of adjacent angles, we read adjacent angles are two angles which are having common vertex, common arm, and the non-common arms lie on the opposite sides of the common arm. So angle 1 and angle 2, they are adjacent angles. Similarly, angle 1, angle 4, they are adjacent angles. But angle 1 and angle 3, they are non-adjacent pair of angles. Similarly, angle 2 and angle 4, they are non-adjacent pairs of angles. So thus here in this figure 1, we are having four angles, and the non-adjacent angles that are formed by the intersection of these two lines, those non-adjacent angles are called vertically opposite angles. Thus in this figure, angle 1 and angle 3, angle 2 and angle 4, they are vertically opposite angles. And there's a property related to vertically opposite angles, and it is given in the form of a theorem which says if two lines intersect each other, then the vertically opposite angles are equal. Just like here, we are having these two lines L and M which are intersecting each other and forming four angles, angle 1, angle 2, angle 3, angle 4, in which angle 1, angle 3 and angle 2, angle 4 are vertically opposite angles. So we are having two pairs of vertically opposite angles here, and as per the theorem, we have to prove that vertically opposite angles are equal. That means we have to prove angle 1 is equal to angle 3 and angle 2 is equal to angle 4. Let's prove this statement. So we are having the figure again here, L and M intersecting each other, forming four angles, angle 1, angle 2, angle 3, angle 4, and we have to prove that angle 1 is equal to angle 3, and we have to prove that angle 2 is equal to angle 4. Let's give the proof of this statement. We know that here angle 1 and angle 4, they are forming linear pair of angles as they are adjacent angles and the non-common arms are forming a straight line. Thus, their sum is 180 degrees as per the linear pair axiom. Angle 1 plus angle 4 is 180 degrees. Similarly, if we will see angle 1 and angle 2, they are also forming linear pair of angles. So angle 1 plus angle 2 is again 180 degrees. If we will see from equation first and equation second, The sum of angle 1 and angle 4 is 180 degrees, and angle 1 and angle 2, their sum is also equal to 180 degrees. And we read and we know from the Euclid's first axiom, when two things are equal to the same thing, then they are equal to one another. This, using the Euclid's axiom 1, we can say from first and second, we get angle 1 plus angle 4 is equal to angle 1 plus angle 2. Then we also know from axiom third, if equals are subtracted from equals, wholes are also equal. So we will subtract angle 1 from both the sides. So here plus angle 1 and minus angle 1 will be cancelled. Similarly, plus angle 1 and minus angle 1 from the right side will also be cancelled. So we'll be left with angle 4 equals angle 2. And this was one of our vertically opposite angle pairs. And we proved that angle 2 is equal to angle 4. Similarly, we can prove that angle 1 is equal to angle 3. Thus, we proved that vertically opposite angles are equal. So this was all in our today's video tutorial in which we saw different pairs of angles. I hope you understood. Thank you.